Hi everyone and welcome to my YouTube channel. So we're going to continue our IMO playlist, and in this video we'll begin with the second IMO, which was held in Romania in 1960. So in the last two videos we've discussed the first IMO, which was in 1959, and in this video we're going to discuss the second IMO, and we're going to start with problem 1. So as you saw, problem 1 of the first IMO was pretty easy. So will that happen again? Well, let's see and get started. Okay, so the problem statement is the following. So we're asked to determine all 3 digits numbers n such that we have the following two conditions. So the first one is that n divided by 11 is an integer, meaning that 11 divides n, or n is divisible by 11, or it is a multiple of 11. All of these expressions are equal or equivalent. And n divided by 11 is the sum of the squares of the digits of n. Okay, so as you can see, this problem is all about digits of numbers. So we're going to learn how to handle digits. Okay, so actually let's get started with the solution. And actually we're going to start by simplifying like the problem statement. Okay, so first of all, here we know that n is a 3-digit number. So it makes sense to assume that n can be written as the following: a, b, c, where a, b, c is the decimal representation of the number n. So actually we usually denote that by this. So that means that ABC is the decimal representation of number n. Okay, so as we know, A can be only 1, 2, 3 up to 9. It cannot be 0, while B can be from 0 to 9 and C can be from 0 to 9. Okay, so that's for the first line. Okay, the second line states that 11 divides n. So that means that n is divisible by 11. But actually, if you remember, like in school we all learn how the divisibility rule when we divide by 11. So what does it say? Well, actually, if you remember, it states that in order to for 11 to divide ABC or n, we need to have c plus a minus b is divisible by 11 as well. So that means, let's actually write that down. So 11 divides n. So actually this denotes to divisibility, like this perpendicular line. That means that 11 divides n. Actually, this is equivalent. This is equivalent to the saying that 11 divides a plus c minus b. So for example, if you remember, if we want to check whether 11 divides 121, what do we do? So we say 1 plus 1 is 2, minus 2 is 0, but 0 is a multiple of 11. So that means that this number is divisible by 11. And indeed, it is just 11 squared, and so on. Okay, so let's erase that. Okay, so as we said, 11 divides a plus c minus b. But what does that mean? 11 divides a plus c minus b. Well, that simply means that a plus c minus b is a multiple of 11, right? So for example, it can be 0, it can be 11, it can be 22, something like that, because it's a multiple of 11. But remember that a, c, and b have only a small range, because they are digits. So they cannot, for example, exceed 9, and they cannot go below 0. So if we put that in mind, we can actually immediately get a very nice result, which can make our solution pretty simple. So actually, a plus c minus b, what is the range of this number? Well, let's take a look. So first of all, let's take a look here. A plus c minus b. So let's give this an upper bound. So we know that a is smaller than or equal to 9, and c also it's smaller than or equal to 9, while b, we want here to have negative b is great, so we want simply to make b 0, right? So like this is smaller than or equal to 18. And of course, this is satisfied, the equality, when A is 9, C is 9, and B is 0. Okay, great. So this number or this expression is simply less than or equal to 18. What about a lower bound? So this is greater than 0, this is greater than or equal to 0, while this is greater than or equal to -9, right? Because we want to maximize B in this case. So simply this is greater than or equal to -9. And of course, actually here we can even say that -8 because A is greater than or equal to 1. Okay, but this is not so important. So actually, now we have this interesting inequality. And actually now, like, you can immediately get a very nice result. Because remember, this number, this expression, is divisible by 11. And what are the multiples of 11 that are in the range from -9 to 18? Well, they are simply 0 and 11. Great, so like A plus C minus B has two cases. It can be either 0 or 11. Okay, so let's write that down because like this is already half the way of the solution. Okay, so now we can immediately put the two cases. So now we know that A plus C minus B has two cases, either 0 or 11. And now the plan is simple. We're going to discuss the two cases separately. First of all, we're going to discuss A plus C minus B is 0, and then A plus C minus B is 11. And we will find a solution for each one of the cases. Okay, so actually let's erase everything and start by discussing the first case. Okay. Okay, so case 1. So we'll start with case 1. Let's write that down here. Case 1, A plus C minus B equals 0. Okay, so what does that mean? So if A plus C minus B is 0, that means that simply B is equal to A plus C. Straightforward. Okay. Now let's actually take a look at the rest of the statement. Because remember, n over 11 divisible or n divided by 11 is the sum of the squares of the digits of n. Okay, so first of all, what are the digits of n? They are a, b, and c. The sum of the squares of these digits, that means a squared plus b squared plus c squared. So that means that n over 11 is just a squared plus b squared plus c squared. But wait a minute, what is n over 11? Well, remember, n is just ABC. So that means that we can write n as the following. Okay, so we know that n over 11 is simply 100 times A plus 10 times B plus C. Because after all, like this is how we write the decimal representation of any number, right? We multiply the 100 digits by 100, the 10 digits by 10, and we have C like itself. We don't multiply it by anything. Okay, and we will simply divide this by 11. But remember, what is B? B is A plus C. So it makes sense to substitute B with A plus C. Okay, so let's actually substitute B with A plus C. And actually, you can immediately see that B will going to be A plus C. That means that here we're going to have, instead of 100, we have 110 A plus, here we're going to have 11C divided by 11. And of course, you can see that we can immediately divide by 11. That will be just simply 10A plus C. Great. So that means that n divided by 11 is simply 10A plus C. Okay. And now we know that 10A plus C is simply A squared plus B squared plus C squared. So now actually we know that this number is equal to A squared plus B squared plus C squared. So let's write that down. So actually now we know that this is A squared plus B squared plus C squared. Okay, but remember, we know that B is A plus C, so also it makes sense to substitute B with A plus C here, and then we're going to have a much simpler equation with just two unknown variables. So let's actually write B as A plus C and like expand this. Okay, so we're going to have the following: a squared plus c squared. So this will be 2a squared plus 2c squared plus 2 times ac. So actually let's write that down. And actually we'll immediately like try to group everything on one hand side in order to have like a second degree equation. For example, let's say that our variable here is a. So for example, we're going to consider a as x in any normal second degree equation. Okay, so simply we're going to write the following: a squared, and this will be, as we mentioned, 2. So actually let's expand it here. So we're going to have 2a squared plus 2c squared plus 2ac. So actually here we need not to write a squared but 2a squared. And then what are like the coefficients of a alone? So we have the following: plus 2c here, and here we have minus 10. Okay, so here we have a, and then we have like the free term, which is c squared, or sorry, 2c squared, because we're dealing with this one here. Okay, and here we have minus c. So something like that. And simply this is 0. Okay, so let's make sure that everything is true, correct. So here we have 2a squared, okay, and then the coefficients of a from here, 2c minus 10, and then we have 2c squared minus c. Okay, and simply, ladies and gentlemen, we have a simple second degree equation with coefficient, or sorry, with variable a here, unknown variable a. So we can simply find the delta of this equation, and we know that this delta, because we are dealing with integers, this delta must be a perfect square, because when we are going to take the square roots of delta, then that must be an integer, right? Okay, so let's actually evaluate delta of this expression. Okay, so let's find out what is delta here. So delta here is 2c minus 10 squared, okay, minus 4 times 2, which is 8. So 8 times 2c squared minus c. Okay, so let's try to expand and cancel some stuff. So here we have 4c squared, here we have 16. So 4 minus 16 is negative 12c squared. Okay, and then we have minus minus 40c, and here we have plus 8. So that means this is minus 32c. I hope we don't make any mistake. And then we have plus 100. Okay, and this is delta simply. Let's make sure everything is all right. So 4c squared. So 4 minus 16 is minus 12. We have minus 40 plus 8 is minus 32. Okay, and here we have plus 100. Okay, so this is delta. This must be a perfect square. But take a look here. We can simply take the 4 outside, right? Like as a common factor. So let's actually take the 4 as a common factor. In fact, let's take minus 4 as a common factor. And then that means we have 3c squared plus, here we have 8c, and here we have minus 25. Okay, so simply this is delta, right? So let's actually remember that this is delta. Like this is delta, this expression. This must be a perfect square. But actually, you can immediately see that this seems to be negative, right? Because take a look, here we have a negative sign, and this seems to be positive for the majority of values of c, except when c is 0. Because if c is 0, take a look, this will be negative 25, so minus times minus, this will be positive. And in fact, this is our first solution, because take a look, 4 times 25, this is a perfect square. Great, so we have one case when c is 0, that works. We need to discuss that. But what about 1, when c is 1? So when c is 1, we have 3 plus 8, 11. 11 minus 25, this will be 14. 3 plus 8, yes, is 11. 11 minus 25 is minus 14. But minus 14 times minus 4, this is not a perfect square, right? Okay, so we need to exclude that. So c equals 1 doesn't work. What about c equals 2? Well, 4 times 3 is 12. 12 plus 16, this is 26. 26 minus 25, this is 1. So that means that delta is negative. So in fact, any value from 2 and like going greater than 2, this will make delta negative, which means that like we don't have any solution, right? So that means the only case here, the valid case, is c equals 0. Great, so now we know that c equals 0. Okay, so let's try that. Maybe we can figure out our first solution, c equals 0. Okay. Great, so now we know that c equals 0. What about a? So in fact, let's just take a look, where were we? So here we were. So our equation now is simple, because it's the following. 2a squared minus 10a is 0, right? That means, of course, a cannot be 0. We mentioned that. It's the 10 because it's the 100 digits. So it cannot be 0. So we can simply divide by a. That means that a is simply 5, right? So that means that a is simply 5. Okay. So now we know what is a and what is c. What about b? Well, remember, b is simply a plus c, meaning that b is simply 5 plus 0. So b is 5. So you can simply see that b is 5, and that means that we have trashed our first case. So what is the number n? We can simply say that the number n in this case is 550, which is actually our first solution. So you can actually check that. So if you divide this number by 11, you will get 5 squared plus 5 squared, which is 50. So let's actually check that. So n divided by 11, that means 50, is equal to 25 plus 25, which is 50. So that means that this is our first solution in the first case. Great. So now we are just left with our second case. So like this problem is a bit boring after you find this, because like you just need to expand and do some delta. Okay, but luckily we'll just repeat the same process again, and hopefully we're going to solve the second case as well. So case 2. A plus c minus b equals 11. Okay, great. So actually we will repeat what we have done earlier again. So in this case, what are we going to substitute with? Well, let's see. Well, actually I prefer to substitute here c. So in fact, I'm just going to do this time. C equals b minus a plus 11. And I'll just substitute c with this thing. Well, just because like c is on the right hand side. If you remember, c is the unit digits, so like it's much simpler to deal with. But of course you are free like to pick whatever you want to substitute with, because you will just reach the same solution. Okay, so let's actually substitute c here. So this time n over 11, we'll just do the same again. Remember, n over 11 is simply 100a plus 10b plus c over 11. Now this c is b minus a plus 11. So minus a, that means 99a. Plus b, that means 10b. And plus 11, plus 11. Divided by 11. Well, simply this is 9a plus b plus 1. And of course, 9a plus b plus 1 is simply a squared plus b squared plus c squared again. So we can just write this is the sum of a squared plus b squared plus c squared. But remember, c is simply b minus a plus 11. So this is b minus a plus 11 squared. So like actually this is like much harder than the first case, because like we have here three things that we need to expand. Okay, but no problem. Let's expand this. Okay, so first of all, we're going to have a squared. So actually let's expand it maybe here. So we're just going to expand the right hand side. So first of all, we have a squared plus b squared plus a squared plus b squared again. So we can simply multiply this by 2. And of course plus 11 squared. And then we have minus 2 times ab. And then plus 22 times b minus 22 times a. And here we have 9a plus b plus 1. So actually we have this is 9a plus b plus 1. So let's try to cancel some stuff here. So first of all, let's actually group that as before. We're going to consider this like a second degree equation with variable a here, unknown variable a. So we're going to have again 2 times a squared. And let's see what is the coefficient of a. So here we have minus 2ab. And here we have minus 22a. But here this will going like this will be 9 plus 22, and simply we have 31 here. So okay, so this is minus a times 2b plus, okay, as we mentioned, this is just 31. I hope we don't make any mistake here. Okay, so then we're going to have b. So plus something here, which is 2b squared, and then let's see, we have 22b, and we have b here, so this is 21b, and then we have 121 minus 1, so this is 120. Okay, and this is simply 0. So let's make sure that we haven't made any mistake. So 2a squared is 2a squared here. Here we have a 2b minus 2b. And then we have 22 plus 9. This is just 31. And then we've got rid of a. Then we have the free quantity here, which is 2b squared. Then we have 21b plus 120. Okay, so like this is our equation now, and we simply need to evaluate delta as before. Okay, so what is delta? So let's see. So delta is really ugly. 2b plus 31 squared minus 8 times 2b squared plus 21b plus 120. Okay, and we need to expand that. So actually, in order to expand that, let's first of all erase. Maybe we're going to erase what? Okay, this line here, because like this is really boring and we don't want to make any mistake, any calculation mistake. So actually this will be 4b squared minus 16. So 4 minus 16 is minus 12. So minus 12b squared. Then we have plus 2 times 2, which is 4. 4 times 31. 4 times 31b minus 8 times 21 minus 8 times 21b. And then we have 31 squared minus 8 times 120. Okay, so this is delta. Actually, we can evaluate this because we can take 4 as a common factor, and this will simply be, let's see, 31 minus 42, and this is simply 11 actually. Okay, great. So you see, like, we don't always need to evaluate everything, because we can, for example, here take a common factor as 4, and then we need to multiply it by 4. So this will be simply 44, minus 44. So minus 44 here. So let's take the minus outside. 12b squared plus 44. And now this should be, b, minus this number. Okay, so what is this number? Let's calculate it. Okay, so 31 squared times 31, 39169. Okay, so this minus 8 times 120. Okay, so 2 times 2, 8 times 2 is 6, and 8 times 1, this is 9, 0. Okay, so simply this is just 1. Okay, great. So like this is 1. Okay. I hope we haven't made any mistake. Come on, this is not like, this is IMO, not a calculation problem, right? Okay, so this is the case here. So this is delta minus 12b squared plus 44b minus 1. This should be a perfect square. Well, of course, this is not a perfect square, right? Because take a look. If b is 1, this will be negative. But that means that simply b is 0. Because this is the only case when we have delta is 1. So that means that b is 0. 0. Okay, what about the other numbers? So now actually our equation, let's see. Okay, so this is our equation. Our equation will become the following. 2a squared minus 31a plus 120 is 0. Okay, so I believe we can factorize this. 2a, let's see, 8. Okay, so this, if we divide this by 4, okay, so actually this will be, how can we factorize this? 4 times 30, or I believe we can put negative, and 8 and 15. Will that work now? So let's see. So minus 15 minus 16. This is simply minus 31. Exactly. So this is 0. So that means that simply a equals 8, because 2a cannot be 15, because that means that a is not an integer. So a is 8, sorry. So that means that a is 8. Okay, and what is c? Well, c, that means c is simply 3. Okay, great. So that means a plus c is 11 minus 0, which is 11. Great. So that means that our number in this case is n equals 803. Exactly. So this is n in this case. And of course, you can check that again. You can divide this by 11, and you will get that this is 8 squared plus 3 squared. And our first solution, if you remember, it was 550. So that means like these are the only two solutions. Solution 1 and solution 2. And that means, ladies and gentlemen, we're finally done after doing all these boring calculations. Alright, so let's see like what we have done in this problem. So first of all, we saw that this is a 3-digit numbers. That means that n is simply ABC, the decimal representation. Then we've concluded since n is divisible by 11, that means that a plus c minus b can be either 0 or 11. And that's like a very important thing that you should consider when solving a digit problem. You should always think about inequalities, because remember, the digits are not like any random number, any random integers. They have a small range, so only from 0 to 9. So that means like you can always deal with inequalities or use inequalities to like find beautiful results when you are solving a digit problem. Okay, then after we've done that, we've simply like discussed the two cases separately, and then like we've done lots of boring calculations in order to solve this question. So I believe that like this question, of course, it's much harder than the first problem from the first IMO, but like it contains lots of calculations, of boring calculations, like, and you can easily, during the contest, under the pressure of the time, you can easily like make maybe a calculation mistake. So okay, so we're done with this problem, and in the next video we're going to discuss problem 4 of this IMO. So I hope you guys enjoyed the video. If you did, like, share and subscribe to the channel, and see you guys in the next video.